I will start by giving you an overview of the synoptic situation over Europe. Then Natasha will take over, Natasha Stralec-Machovic from the Croatian Met Office, and she will analyze much more in details some situation of the weather pattern today. And then at the end, Ivan Chonevsky from ECNWF will give you an overview of the monthly expected weather. Okay, so I'm starting now. Just very simple overview. This is a picture taken from a commercial website in the internet, and it's showing the radar, the precipitation from the radar. Today, 17 June at 7:45 UTC, and also some lightning. So you can see that there is some observed precipitation over northern part of England, western part of Scandinavia, Denmark, and then you can see also in the Mediterranean area over Italy and western Balkan areas, a lot of activities, lightning activities, and rain areas over the eastern part of Europe, close to Ukraine and western Russia. So what is happening? So you can imagine a person that is looking at the internet and is having a look at this picture. So now we are going to together, with the help of this later of Natasha, to understand what is going on, to have a look inside the weather patterns. Okay, so I start with one of my favorite satellite pictures. This is the AirMass RGB, and I like because it's very colorful and very clear for me. So the AirMass RGB usually can help us identify air masses. Usually the thumb rule is that warm air masses are represented by these greenish bluish colors, and colder air masses with more violet cold colors, so violet and red colors. So you can nicely see, if I could use the annotation, maybe I don't know if you see my mouse, but yes, you can see that we have here on the Atlantic area, we seem to have here a warm air mass here over the Atlantic, so next to on the west part of Portugal and France. Then and above it we have a cold air mass over the northern part of Atlantic, between so roughly between Greenland and Iceland and the northernmost part of British Islands. Which is very interesting to see is this, you can see with this reddish color, this cold air intrusion from the northern part of Europe towards the Mediterranean. So you can see that there is this cold air pool over the western Mediterranean, most part of Italy, and then up to the northern Europe. And then again, we can see the border here in the northern part of Africa and the eastern part of Mediterranean. There is the warm air mass. Okay, and then now I use to support this analysis made only with the help of the satellite picture. I use the numerical fields. Here you can see in this picture, again, 6 UTC today, you can see overlapped with the air mass picture, you can image, you can see the temperature and dew potential height at 500 hectopascal, and you can see that it is very much supporting this this picture we just gave. So we have very warm air mass west of Spain and France, and then we have this cold. You can see really very nicely if you see at the -12 temperature curve, you can see this cold air intrusion from the north of Europe into the Mediterranean, into the Western Mediterranean and over north of Italy. So this is a very nice signals, nice support from the numerical fields. Okay, let's go ahead again. Very simple things. This is the water vapor image. Same time. Today 6:50 C, and I usually like water vapor image because they can help us identify the jet streams, jet streaks. So usually the jet streaks. So the core of the jet stream is usually located at the border between the very dark areas or the very dry areas, and we can nicely see that the jet stream seems to be located here at the border of the warm and cold air masses. So here over the Mediterranean, there is a nice jet stream continuing towards British Islands, and then Norway. Then we have another jet stream which is from Norway going through Latvia and all the way towards north part of the Alps and towards Spain. Then there are other jet stream all over. So I see also something here in the western part of Mediterranean above Tunisia. So there is another jet stream. Okay, now let's see what the numerical fields are telling us, how they're supporting this this very simple analysis. Yes, it seems now you have here overlapped with the water vapor image. You have we have the isotouches at 300 hectopascal. So, and we see a good, they're supporting really very nicely what we were telling. Which is there are some interesting features here that, for example, you see over here over Central Europe, the jet stream over Central Europe. If you look at the jet stream, the core is not really following the border of the sharp area, but that may be because the this is just a pressure level section, so maybe the core is a bit higher, so getting higher, maybe it's getting toward the right position we get from the water vapor image. Let's have again another composition that can help us analyze the fronts. Here we have infrared picture overlapped with the equivalent thickness field. And we can really nicely see where are the fronts. So the fronts are located at the warm edge of the area where the density of the equivalent thickness is the highest. So we can nicely see that there is the surface front will be located here over the Mediterranean, below over the Atlantic, below these rain bands, and then stretching over to the British Island, across the middle of the British Island. And then we nicely see that there is the warm front here, stretching from North Sea to the northern France, and then occlusion. This is a very nice occlusion. So the warm air is lifting up. We can see another feature here over the western part of eastern part of Europe, western part of Russia. There is another front. See here, you remember in the beginning there was this some precipitation area here connected to this front, and then over the Mediterranean is always very difficult. The Mediterranean is always to analyze the front of over the Mediterranean, because there must be also the impact of the warm surface, and then there is orography and all kind of things. So it's very difficult to see if there is a frontal structure there. But it seems to me like kind of cold front and maybe a kind of occlusion, but that's a different story. So I've just given you a very broad, very simple overview of the synoptic situation above Europe. And now, with pleasure, I give the microphone I give the floor to Natasha, who will concentrate on focus on more detailed features of the weather today. Thank you very much.
Okay, hello everyone. I hope you can hear me well. As Alessandro already pointed, and you can see from the large-scale synoptics situation, there are actually 2 points of interest over Europe today, or let's say Europe and the Atlantic. Here is this northern front, which is approaching Europe from the west. So this is the system that we should take care of, or look what it will develop into. And then there is another system. There's this low over Mediterranean, Adriatic, and southeastern Europe, which we also should take care of. So I will start with the northernmost system and show you an interesting feature that I have found in the images from tonight. First of all, the low is, as you can see, the spiral is connected to the upper level low in 500 hectopascal. You can also see that the potential vorticity values are quite high, or if you look at the values here, this actually shows you to which pressure level has the 1.5 PVU come down. So actually here it came down almost to 700 hectopascal, and here even lower. So actually quite a deep intrusion of the air from the above, from very high troposphere and even lower stratosphere. And this area should be watched at. Whether it will evolve further or will it dissolve, this is the question now, but we'll look at the forecast images a little bit later on. What I wanted to point to you was this area here, this upper level low, actually around the center, because I found an interesting feature looking at the wind field. So the wind, obviously, from the model is consistent with the location of the low in the water vapor image. And you can nicely see where the maximum wind is found. So it is along the coast of the Greenland, and then here over the Atlantic, northwesterly and westerly wind picks up around the low. What is interesting is if you compare this image, which is a model image, to the ASCAT overpass images, I will quickly overlay this. You can see that another maximum appears, which was not contained in the model, and this is this red area here, which is nicely seen in the ASCAT overpass, however not captured by the model in this area. Could be time difference, time shift, I'm not really sure what it is, but it looked to me as a nice feature to show the ASCAT overpass and how well it actually correlates with the model analysis. So this is this northern feature, which we will see later on in the forecast will move towards southeast. And then I just quickly jump to the southeast of Europe, where we have already early morning quite some convection developing. This image here is severe storms RGB, which actually is used to show you the microphysics of the convective storms developing in this area. And obviously there is quite some convective storms developing already very early in the morning. If you look at the temperature of the cloud tops, it is not severe yet, but it was early morning, so we can still expect things to develop further on. Everything happens in the upper level trough, very close to this upper level low over central Italy. So we can expect the situation to develop even further. So precipitation and winds are to be expected in the area. If you look at the air mass RGB overlaid with the winds already with the isotox, as Alessandro already pointed out, this is one of the jets that could be seen also in the water vapor image. And you can see here nicely that the left exit region of this jet streak here over Mediterranean is actually playing a role in enhancing this convection over the Adriatic, central Italy and the Balkan area. So this convection as well as this northernmost system are two systems that we would like to take care of. And if we switch to the forecast given by the STFX crew, we can see that they pointed out this area really clearly as the area where the most convective development can be expected. Even the orange area points that there is 5% probability of severe thunderstorms in the area of southeastern Europe. So going to the forecast, since we are in ECMWF, it seemed reasonable and nice to use just a few forecast images to show you how the situation is developing. So we are looking at the trough here that we saw at 6 UTC was a little bit more to the east. This is a 12 UTC forecast. So today at 12, the trough will obviously move further east towards North United Cape, and the low over the Mediterranean is still continuing to influence the weather over the whole Italy, Adriatic and southeastern Europe. It is slowly moving to the east, but still being in the same area. In the next one, so this is the image tomorrow at 12, you see that the direction of the wind has changed from westerly to northwesterly over the UK. I expect some winds to pick up here in this area, also along the coast of the Netherlands, Belgium, also along the coasts of the Baltic states, probably some high winds tomorrow. And as you can see, the upper level low in the southeastern Europe is still here, but moving slowly towards the Mediterranean Sea. In the forecast data, well, what is interesting if you think of the forecast is the precipitation. If you look at the precipitation for today, then of course the area into which the upper level trough moves is the area of the highest probability of precipitation. This here are the probabilities from the ensemble model of the probability greater than 5 millimeters. So here you have probability 95 to 100% of probability greater than 5 millimeters in the area of the North Sea and the southern Scandinavian. And also here in the southeast Europe, quite high probability of precipitation. Whereas if you go to tomorrow, the probability gets lower. Obviously, the upper level trough or the low moves further to the east, and the probability of the precipitation is now highest at the Baltic states, North Sea, so in this area. And it also moves towards Greece, so tomorrow Greece should expect some heavier or more precipitation than the other areas. As you can see nicely, also the cold front that was moving over Western Russia is still here and still will produce precipitation even tomorrow. As for the winds, if we look at the probabilities of the wind gusts, as I told you in looking at the synoptic images, here is the very high probability of high winds. So over the North Atlantic, northern part of the UK, here Belgium, and here probably also towards the Baltic states. So this is the area where high winds can be expected. As you can also see, connected to the low in the Mediterranean, some high winds also here. For tomorrow, this probability is a bit lower here over the Atlantic, but still high winds, so Northern Europe and here in the Mediterranean. This goes along quite well also with the warnings that were issued today. So warnings that could be issued also based on the extreme forecast index. If you looked at the precipitation, again, extreme forecast index for precipitation points out today the area of Scandinavia and the area of southeastern Europe. For the winds for today, North England, so North Scotland and north part of UK, here some parts of Scandinavia, and again large portions of Mediterranean could experience some high winds. Hence the warnings for Europe for today. As you can see, colleagues from Italy and also in the southeastern Europe all have taken into account the high probability of rain and the high probability of strong winds, issuing the warnings for this area. But you can also notice the coastal warnings here, Netherlands, which is connected to the high winds there, and also here over the Baltic states. So these are the areas that could experience some severe weather today. This is about the weather today and tomorrow. And now we are moving to a long-term forecast. I'm giving my word to Ivan from ECMWF.
Hello, everybody. So I'm going to show you the recent monthly forecast from ECMWF, and I'm going to focus on the 2-meter temperature anomalies for what we call week 2 forecast. So this means the weather for next week. So on this slide, you can see the temperature anomalies over the continent forecast for the next week. So cold anomalies over Western Europe, very weak or no signal over eastern part of the continent. So this forecast, the recent one from Monday, suggests that we can expect cold anomalies, so a little bit cooler weather over Western Europe during next week. But this is an interesting situation because in the far medium range beyond A10, we see very often quite high uncertainty, large spread. So if we look at the weather forecast from previous Thursday, so the previous monthly forecast, we'll see quite a striking difference between these two runs of the monthly forecast system. So instead of this cold anomaly over Western Europe, in the previous run, we see this warm, nice weather over and the western part of the continent, including the UK. And here in the UK, we are quite happy to see such warm anomalies because normally here it's quite cool and rainy. So in some sense, we are disappointed to see this change in the signal from warm to cold weather. But the interesting question is why? What happened that changed the forecast, and what's different in the latest forecast compared to the previous one? So on the right-hand side, you can see the mean sea level pressure anomalies over the continent. So in the Thursday's run, quite widely, we can see this high pressure. So kind of a blocking regime. This suggests kind of a blocking regime. And now instead of this positive anomaly, we see some negative anomalies in the mean sea level pressure, suggesting some cyclonic activity over the continent for the next week. If we compare, if we go further back and compare the recent forecast with the forecast issued 3 weeks ago, we'll see quite a big jumpiness, and that's what often happens in the monthly forecast. The signal from week 3 to week 2, it can change from time to time. So for week 3, from the forecast from the 4th of June, we see some warm anomalies across Europe. Then the anomalies suddenly disappear, these warm anomalies, and the signal became less statistically significant, and then again warm anomaly, and now we have this cold anomaly over the continent. And in the monthly forecast, so on the ECMWF web page, we also provide charts that show the flow patterns. So these are the two most recent forecasts. So, and you can we can really see the sharp change in the forecast from positive anomalies at 500 millibars to this cyclonic pattern over Europe, and this reflects also on the probability charts. The right hand side show the probability of temperature to be in the upper tercile of the distribution, of the climate distribution. So from quite high probabilities of warm weather, now we end up with quite low probabilities of this to happen. And this shows also, when we look at the forecast distribution, we also focus not only on the upper tercile but also the lower tercile, and you can see here the maps for the lower tercile as well. If we look at a specific location, in the example here, this is Brussels, we can see what actually happens in the red square. I just highlighted the area where the validity period, so the forecast for the next week from the previous run, we can see this gradual increase of temperature at 850 hectopascals, implying some warming, and now it's quite flat at lower temperatures. The latest forecast. For in the medium range, we also provide on the web these nice charts that show the clusters. So in these clusters, we can see quite big spread across Europe. Most of the clusters actually suggest these westerlies, so fast-moving waves across the continent from west to east, with some troughs that may develop. Some of these troughs may become even quite deep and form cutoff flows, but of course the uncertainty is quite large. So, but this helps us to actually to see different weather regimes, and to also to calculate the probabilities of each of these weather regimes. And we can see here that actually almost all the clusters suggest a kind of a westerly flow, with some differences actually in the weather patterns, but they are quite significant, and this implies this a large spread in the medium range we are having now, and forecast even further in the medium range, the far medium range. So this suggests 20 members of the ensemble distribution show this westerly flow, that this flow will continue, but the other 31 members actually suggest that we are going towards some kind of a blocking conditions, but be careful, because this blocking is one of the most difficult weather regime to forecast, and especially the transition from westerlies to blocking. This is quite difficult, but anyway, this shows us that we have to be careful and we have to be aware of these possibilities. and this actually decrease our confidence in the forecast. And at the end, I'd like to show this new product that we provide on the web. This is the EFI. We extended the EFI for 2-meter temperature, total precipitation, and the wind beyond day 10. Now you've got this 5-day average EFI for 5-day average temperature, for example, over Europe. And this actually shows that usually we've got quite weak signal just because the spread is quite large, but it could be quite useful as well because in the Atlantic we see this dipole structure, negative anomalies in the northern Atlantic and to the south warm anomalies. These are related to the sea surface temperature anomalies, but this obviously creates quite steep gradient, temperature gradients in the in this part of the Atlantic, just to the west of the British Isles, and the frontal zone obviously is here. So this triggers quite active frontal zone here, and weather patterns moving across the Europe from the west. That's what we expect for the next week, and also for the week after. And the CDF here for Reading, I plotted, and it shows the whole forecast distribution in red. So we can see that the spread is actually the forecast is not far from the climate, the model climate, but we can see this slight shift towards cooler temperatures. So to summarize this for the next week, this analysis of the forecast actually suggests that next week we are going to have westerlies over Europe with frontal zone crossing the middle of the continent with waves traveling from west to east, bringing some unsettled weather, changeable weather in over the continent. So no big no heat waves are likely over much of Europe, except this part of eastern parts of Europe, where we can see some suggestions of warmer conditions, even positive SOT black contours here, which suggests some extremely high temperatures over this region. What we can say now for the week after is that it's quite uncertain whether these westerlies will actually continue, or one of the waves will break and will create these blocking conditions. So that's what we'll focus on next days to see what's the most likely outcome. So thank you very much.
Okay, thank you very much to Natasa and Ivan. Very wonderful contribution. So this, so today I wanted to also to make clear to the other participants from Europe that today also most of the participants of the EUMeTrain workshop here in ECNWF are attending this briefing from a big room. So it's really a chance to show to these people how this is kind of methods of delivering training. The idea is that through the analysis of the actual weather, we can improve the skills of forecasters who are attending the briefing to analyze to the different features of the satellite picture, of how to combine with numerical models to understand the conceptual models and so forth. So this was kind of showcase for the EUMeTrain participants.